Welcome back. Welcome back, welcome back, welcome back. We're back in looking at the grade 8 Gauss paper from the year 2000, and we're on to question number 23, which is a delightful little question. It's got some hexagons in it, and let's find out what it says. A square floor is tiled, as partially shown, with a large number of regular hexagonal tiles. The tiles are colored blue or white. Each blue tile is surrounded by 6 white tiles, and each white tile is surrounded by 3 blue, 1, 2, 3, and 3 white. Ignoring partial tiles, the ratio of the number of blue tiles to the number of white tiles is closest to what? So what we have here is a bunch of ratios, as the question is asking us for a ratio. And so what we could probably do, and this is a fine way to do it if you don't have any intuition behind it, but you still want to try the question, is I would repeat this pattern for a very, very large number of tiles appropriately arranged, and count up the number of whites and count up the number of blues and see what ratio it's closest to. The bigger your picture, the bigger your diagram, the closer you will get to the proper ratio. So that is one approach. I think it's a little time consuming, and all you're going to be able to do is eventually you'll be able to rule out this one, and then eventually you'll be able to rule out this one, and this one, and so on. That's the best that you can really hope for. And so the problem is if you don't end up, if you can only show that it's close to 1/4, but you can't rule out 1/2, you're going to have to make a choice in the end. Now, hopefully, that's not how it would end up. It would become clearer and clearer that it's just getting closer and closer to 1/4, or 1/4. But there's a way we can try and approach this using math. And what we're going to do is we're going to sort of count up the number of white tiles in terms of the number of blue tiles. And obviously, we'll count some tiles twice, and we're going to try and account for that. So what are we going to do? Let's draw a little bit of our picture. So hexagonal pattern. So I'm going to stop in a little bit, but if you wanted to, one way to do this question is to just keep making bigger and bigger arrangements and see what the ratio is getting closer and closer to. I think that should just about do it. Maybe a couple more down here. All right. So where are our blue tiles? Let's make this a blue tile, and around it we must have 6 white tiles. And around each white tile we're going to have 3 blues, 2 whites. So here's another blue. This one over here would be another blue. This would be another blue. This would be another blue. This is another blue. This is another blue, and this is another blue. Okay, so if we want a little bit more, so what we can do right now is just sort of count up the number of whites and blues that we see and see if we can get an idea of what the ratio will be. But I don't think that's really the best way to do it. So let's pick one. I'm going to say blue tiles. And we're going to let B be the number of blue tiles. Okay. So how many white tiles are there? So for each blue tile, we know there are 6 white tiles. Okay. That's for every single blue, we can find 6 white tiles around it. So one might think that the ratio is 1 blue tile to 6 white tiles, and indeed, that is A. So if you just wanted to jump in there naively and say, well, it's 1 to 6, you could try that. You'd be wrong, and I'll show you why. If I pick a single blue tile, let's say this one, I can count 1, 2, 3, 4, 5, 6. I have 6 white tiles around this single blue tile. everything seems fine until I count this blue tile up here. So here's 7 white tiles, 8, this is our 9th one, this is our 10th one, 11th, 12th. But you'll notice that these 2 white tiles have now been counted an extra time each. And things get even worse when I then say, okay, what about this blue tile? Well, we have 12 white tiles, here's our 13th, our 14th, our 15th, 16th, 17th, and 18th white tiles. So I've counted 18 white tiles. I have 3 blue tiles. I've counted up 18 white tiles. But some white tiles are counted extra. This one here in the middle has been counted 3 times, when if we're trying to count up the number of white tiles, we really only should be counting him once. And these ones beside him have been counted up twice. And if I were to then say use this blue tile over here, I'd get to 19, 20, 21, 22, 23, 24. This white tile has been counted a 3rd time. So why is this happening? How many times do white tiles get counted? Do all white tiles get counted the same number of times? Each white tile is counted once for every blue tile it is next to. Each white tile is next to exactly 3 blue tiles. So we count each white tile 3 times. So we need to reflect that. Yeah, 6 times B, that gives you a rough estimate for the number of white tiles. But we're counting each tile 3 times. So in fact, the number of white tiles is going to be 6 divided by 3, which is 2 times the blue tiles. So the number of blues to the number of whites is B to 2B, and that's a ratio of 1 to 2. Okay, and hopefully that's one of our answers, and it's E. It's the last one. So for every blue tile, you're going to be able to uniquely find 2 other white tiles. I don't know which ones you're going to pick and why, but that's what you can do. I guess for every blue tile, so this is how I would see it. If I pick a blue tile, I will count the one above it and below it. Okay, so 1 and 2. And then here's 3 and here's 4. Here's 5 and here's 6, 7, 8, 9, 10. And this keeps going, and this works out. This is a nice way to count each blue tile. So if instead we look at it in columns, this is pretty nice. We can just see every blue tile has one above it and one below it, and that's the story. That's it. That's all we need to count. So this is a great way to see that, yeah, we're on the right track. Well, we're not on the right track. We got the right answer, and it's going to be E. So I think that's an excellent little question. Many ways to see it, a couple different ways to try and approach the right answer. I think it's a good question, and as I said, I think it's good. It was good on the grade 7 Gauss as well. So in the next video, we're going to see question 24. We're almost done this paper, and please join me next time for question number 24.